So this guest lecture is coming from my expertise in science fiction studies. Just to let you guys know a little bit about my background, I have a Bachelor of Science in Science, Technology, and Culture from Georgia Tech. I have a Master's in Science Fiction Studies from the University of Liverpool. It's the only master's program in the world that gives that. Then I have a PhD in English from Kent State University, where I did a dissertation on what are called neuronarratives, stories that involve disease and problems with the mind. But it's through these different things that I always have done some work in science fiction. And I thought with this lecture today, a lot of this is about telling stories. I mean, for me, I like stories. It's something that I like to hear what people's experiences are. So I wanted to begin by telling you a little bit about mine. So people ask me, why do I study science fiction? The answer that I usually give them is that my lifelong interest in science fiction began when I was a child, playing on the floor of my family's mobile home in Hortense, Georgia. I mean, out in the middle of nowhere, right? While playing with my toys in front of our massive console television set, my eyes were drawn to the phosphorus light and the deft maneuvering of the Millennium Falcon in an asteroid field. The trailer for The Empire Strikes Back, the second Star Wars film, played on the TV and announced the film's arrival at the local drive-in movie theater. Unfortunately, my folks wouldn't let me go to the drive-in at that age, for non-obvious reasons to a 3-year-old. But I did eventually get to see The Empire Strikes Back, the first of hundreds of times over the course of my life. The thing is, that story's only half true. And I want to share the other half with you guys. While it is true that moment began my lifelong love of Star Wars, it didn't begin me on a trajectory to study science fiction. Instead, it made me want to learn about the science and technology that could make what I saw on the screen a reality. So throughout grade school, I made use of my school's library and the public library in Brunswick, Georgia. They had many nonfiction books that I learned a lot from. These are known as science popularizations. These are meant to popularize science for a lay audience. A lay audience meaning people that have general education but don't have the kind of specialized education that you're all working towards here at City Tech. Following clues in the books, including names, references, and footnotes, I could leverage one book to learn where I should turn next to learn more. At some point, I stumbled on Stephen Hawking's 1988 book, A Brief History of Time, which intertwines his autobiography with the scientific work that he had done up to that point in cosmology and on black holes, which you guys are studying in this class. That book and some sleuthing at the local library led me to Hawking's collaborations. In this case, large-scale structure of space-time with George Ellis, no relation. This was a highly technical work that I was woefully unprepared to decipher in anything but a superficial way. So I sought out more about the underlying principles in mathematics and physics. This led me to Richard Feynman's Lectures on Physics 3-volume set, which are based on the lectures he gave at Caltech from 1961 to 1963. I had read books about the Nobel Prize-winning Feynman already, such as Surely You're Joking, Mr. Feynman, and What Do You Care What Other People Think? These aren't kind of books you would think of like a Nobel Prize-winning physicist would write. But it's through his lectures that I was able to find a breakthrough to better understand the physics that I was interested in. And then these led to other connections. I sought out other collaborators of Hawking, such as Roger Penrose, a mathematician, and I also discovered scientists with whom Hawking debated his theories, such as Kip Thorne, who you might know made a bet with Hawking in 1974. Anybody know about that bet? No? So in 1974, you have to imagine, it was seems like millennia ago, right? That there was debate about this black hole, or this X-ray source, I should say, called Cygnus X1 in the Swan constellation, about whether it was a black hole or not. It was an unusual X-ray source in the sky, and a lot of people were studying it. And the thing is, because these debates were ongoing, and Hawking was someone who was heavily invested in black holes actually existing, that he made a bet with Kip Thorne in order to essentially give himself a consolation prize in case he was wrong, right? And so Hawking believed the black holes exist, and he saw the bet as a consolation prize. If Cygnus X1 turned out to be a black hole, Hawking would give Thorne a 1-year subscription to the men's magazine Penthouse. But if it were not a black hole, Thorne would give Hawking a 4-year subscription to the British tabloid Private Eye. With mounting evidence that Cygnus X1 is a black hole, when Hawking was still alive, he happily paid the bet. So essentially, you prove all this work that you've been doing. And finally, Michio Kaku, the physics professor at the City College of New York and at the CUNY Graduate Center, he was kind of an outlier. I hadn't seen his name until I saw this book appear on the shelf around 1994. But in the book, he talked about how he, during his junior year of high school, or thereabouts, built a betatron. Anybody know what a betatron is? No? You probably might encounter it later on in the class, but it's a cyclic particle accelerator that's used for accelerating electrons in a vacuum. He built one of these things with the help of his parents when he was in high school. It's a device that you can use for experimenting with particle physics. Well, I wanted to do something hands-on too, so I thought that this might be a good starting point to learn something from someone who came before me that had done something really inventive like that. So, let's see, if it says never tried following so much. And this is where our story picks back up with science fiction. So I've got the obligatory group photo, a bunch of people you don't know. This is some of my Boy Scout friends from back in the day. And the person I want to point out here is this guy, Marty Mac. And that's that geeky guy with the thick glasses to his right, that's me. A long time ago. I got my Bo Jackson trainers on, got my Teenage Mutant Ninja Turtle ball cap on. I was about as geeky as you can get back. Well, the thing is, Marty worked at Walden Books. And if you can imagine, in a small town, there's not that many places to get books. And so Marty was kind of my go-to guy to find out new books to read that after I'd already exhausted everything in our local library that I wanted to read. Well, problem is, he unleashed the floodgates for my reading. Not just in terms of the science popularizations, but also with science fiction. And the neat thing about all these books, this is my room back in high school, is that that reading that I did helped prepare me for things that I had to go through at that time. Because I had a number of different colleges I wanted to go to. And one of those was MIT, and all that reading informed what I knew when I had to go give oral interviews with representatives from the school to go through the application process. I ultimately didn't go there, but if I hadn't been doing all that reading, I probably would have sounded like I didn't know anything when I was in those interviews. So there's a lot of power that comes from gaining as much knowledge as you can outside the classroom. But now, Marty also keyed me into science fiction. Because he knew about my interest and my love of science fiction film, with Star Wars. But it's with reading science fiction, he thought he could provide me some new avenues of fueling my imagination. I knew that science fiction books existed, but I didn't know where to begin reading them. Who should I read? What stories would be the most interesting to me? Marty gave me some advice that to begin with 3 of the genre's grandmasters. Isaac Asimov, who someone mentioned earlier, Ray Bradbury, and Arthur C. Clarke. Now, Isaac Asimov and his family, they immigrated to the United States from Russia when he was about as old as I was when I saw them on Nightfall. He was about 3 years old. And it was also at a much earlier date, 1923, if you guys can imagine, almost 100 years ago. Asimov grew up here in Brooklyn. So when he was young, his family moved around a little bit just a little bit to the east of us here, southeast, but he spent those early developmental years here in Brooklyn. His father owned a stationery and candy store. One of the buildings that he rented still exists close to the Grand Army Plaza in Prospect Park. His father sold SF magazines and admonished his son from reading such trash. Of course, what did he do? If someone tells you not to do something, what do? You're going to do it, right? So he's reading this science fiction on the side. He should be like sweeping up the store, and he's sneaking off in the back to read a science fiction magazine. He read the stories and he got hooked. When he went on to become a distinguished biochemist, I mean, he went to Columbia, got a professorship in Boston. All through that time, he wrote and edited over 500 books, including science fiction, the sciences, and he also wrote other things about like the Bible, about Shakespeare. He's a very learned man. An important science fiction editor named Harlan Ellison, who lived in Brooklyn for a while researching one of his books, said once that Asimiov had writer's block once. It was the worst 10 minutes of his life. I wish I could suffer from something like that. But this book here is called Foundation. And it's about a person named Harry Seldon who develops a mathematics to predict the future called psychohistory. It explores how to wield this kind of power and what effect it might have on a society that develops with that kind of knowledge present. It's akin to something you probably encountered in this class when you study quantum mechanics about the observer effect. Next we have Ray Bradbury, born in Waukegan, Illinois. His family moved following his father's work from place to place, ending up in Tucson and then settling in Los Angeles when he was a teenager. He couldn't afford to go to college, but he was a voracious reader and a determined writer. He said that he graduated from his local library at the age of 18, having read every single book that was inside his local library. To write his early works, including his significant Fahrenheit 451. Have you guys heard of Fahrenheit 451? I see a few people have. That's good. This is a really important book that was about censorship and about the burning of books, which is something that was made very obvious during World War II and what the Nazi regime was doing to books that they disagreed with. And other people have done it from time to time. But in order to write Fahrenheit 451, he couldn't even afford to own a typewriter. So he had to rent time on a typewriter that had a little coin box next to it, put a coin in, and it would reset a timer. You get 30 minutes of time for your dime. It cost him $9.80 to write Fahrenheit 451. And he said, nothing like being on the timer makes you write faster than you possibly could imagine, right? Now, most of his science fiction isn't technical. Instead, he uses science fiction to explore human relationships and human history. The Martian Chronicles, the first book that I read by him, is inspired by Sherwood Anderson's Winesburg, Ohio from 1919, about like small town life. And John Steinbeck's The Grapes of Wrath from 1939, about like the Dust Bowl and about the Great Depression. And in this particular book, it's about humanity colonizing Mars while fleeing the nuclear threat of Earth. Confrontations and decimation of the Aboriginal Martians that humanity encounters, and then the return of humanity to a post-apocalyptic Earth. Then finally, we've got Arthur C. Clarke here, who during World War II worked in the RAF, the Royal Air Force, he was British, on the radar early warning system and ground control approach radar. And very important things for like the Battle of Britain and also for helping planes land during like your difficult conditions like your cloudiness, fog, rain, etc. During the war. After the war, he earned what's called a first-class degree, top degree in mathematics and physics from King's College London, prestigious school. Among his post-war successes, he advocated for the use of geostationary satellites for communication purposes. A geostationary satellite, what does it do? As it goes around the Earth, what's unique about a geostationary satellite? It's always in the same place, right? So it's really great for communication because you know where it's going to be and you can always give coverage to wherever you're trying to beam your signals. Now, people had talked about geostationary satellites before Clarke, but his insight was to use them for communication purposes. Now, as a writer of science fiction, he was considered to be one of the best. This was demonstrated most clearly when he collaborated with Stanley Kubrick to write 2001: A Space Odyssey and to create the film. So basically the idea was that Kubrick and Clarke brainstormed the idea for the story together, but then separately Kubrick went and made the film version and Clarke wrote the novel. Not strictly a novelization because they were working in parallel with one another. Now the story itself is based on a short story Clarke published in 1948 called The Sentinel. About essentially like this leftover artifact left by an alien civilization and what effect it would have on humanity when we found it. Now Clarke and Kubrick were actually competing to see who would get out the gate first. Kubrick succeeded in releasing the film before Clarke could complete the novel in 1968, which is why there are some differences between the novel and the film, such as Jupiter being the source of alien transmission, or the destination of the alien transmission in the film, and Saturn's moon of Iapetus in the novel. Though the interesting thing about the film experience that's worth maybe a little bit of trivia about is that when Neil Armstrong and Buzz Aldrin, who are there? Armstrong and Aldrin. Yeah, first humans to set foot on the moon. When they returned from the moon landing and they were asked what it was like, they said that it was just like 2001. Because they had seen the film before they went on and went on their mission. And they said like the visual experience of it was almost identical. Which I think it speaks maybe a lot to Kubrick's special effects guys and some of the research that they did in making the film. And in a sense, the film had already taken them to the surface of the moon before they actually set foot there. Now, in this next part of the presentation today, I want us to kind of get some idea about the different things that science fiction does. Like, how do we define science fiction? Because as you guys probably are thinking about from the beginning of class, there's a lot of different kinds of science fiction that you guys mentioned as things that you're watching or reading today. So what better way to begin this than to start at the beginning? So the first is by this guy here, Hugo Gernsback, an immigrant to New York City from Luxembourg in the early 20th century, who set up an electrical supply company and a hobbyist magazine called Modern Electrics to help sell his electrical parts. Also, he gave us the earliest form of the term of science fiction with something he called scientifiction. You can probably imagine, he's from Luxembourg. Luxembourgish language has German roots. Germans, as you probably know, like to mash words together and create these really long, extrapolated words that take on new meanings from the way that they're assembled. So he basically took the ideas of science and fiction and mashed them together into this clunky word, scientifiction. And he coined that term when he launched the world's first science fiction magazine in April 1926 called Amazing Stories, published right out of Manhattan. And he defines SF, you can see up here on the screen, quote, "By scientifiction, I mean the Jules Verne, H.G. Wells, and Edgar Allan Poe type of story. A charming romance intermingled with scientific fact and prophetic vision. Not only do these amazing tales make tremendously interesting reading, they are always instructive. They supply knowledge in a very palatable form." I'm adding a little bit here that's not up on the screen. New adventures pictured for us in the scientific fiction of today are not at all impossible of realization tomorrow. Many great science stories destined to be of historical interest are still to be written. Posterity will point to them as having blazed a new trail, not only in literature and fiction, but progress as well." End quote. The key points here is that when he mentions the word romance, it's not what we think of like when we go to the bookstore and there's the romance book section. Romance in that sense means adventure. Okay? So there's adventure that has to be a part of the story. Scientific fact, or it has to be based on something we know about how science and technology works. You can imagine something that hasn't been invented yet, but it has to be based in things that we already know. And then that idea of prophetic vision. You have to have an imaginative extrapolation. You have to look at how things might be down the road, what things might be like in the far future, rather than just what we can do right here in the here and now. Next we got this fella here, John W. Campbell Jr., the enormously influential editor of astounding science fiction, which today is known as analog science fiction. In fact, I'll be giving you guys copies of at the end of the class. Defines science fiction as an analogy to science itself. Perhaps this isn't surprising because Campbell attended MIT and ultimately graduated with a degree in physics from Duke University. Campbell suggests, quote, and here's his definition, "Scientific methodology involves the proposition that a well-constructed theory will not only explain every known phenomenon, but will also predict new and still undiscovered phenomena. Science fiction tries to do much the same and write up in story form what the results look like when applied not only to machines, but to human society as well." End quote. So Campbell configures science fiction as a kind of Godwin experiment. Is anybody, you're familiar with that word, Godwin experiment? If we break it up, you recognize the experiment part, but what does Godwin mean? It comes from German.
Thought experiment.
It's a thought experiment, exactly. Godwin has to do with the mind, with the head. And so it's a thought experiment. You're imagining how things might work in a system. So science fiction should explain, predict, and focus on the development of technology as well as the effects of that technology and science on human beings. Then we have Joanna Russ, a Bronx-born feminist theorist and science fiction writer known for her award-winning works including the widely anthologized When It Changed and The Female Man from 1975. She gives us this definition here, quote, "Science fiction is, of course, about human concerns. It is written and read by who? Obviously us, by human beings. But the culture from which it comes, the experiences, attitudes, knowledge, and learning which one must bring to it, these are not at all what we are used to as proper to literature. They may, however, be increasingly proper to human life." End quote. She adds to this human-centeredness idea of science fiction, that it's not just about spaceships and ray guns and robots. All the stories are always about human beings and about the effect of our science and technology on human beings and on our social systems. But she adds that we should be aware of the context from which the story is written. These are, to put it a different way, the initial conditions from the extrapolation that takes place in the story. That you have to start from the place you know in order to imagine something that's different in the future or in a different world. The history and culture that a story derives from is important for our appreciation and understanding of the story. And then just two final definitions. You guys hang in there just a little bit more, and then we're going to get to some examples of science fiction that we're going to discuss today. The two final definitions that I would like to share with you, the first comes from Ray Bradbury, who I mentioned before. He's from Waukegan, Illinois. lived his life in Los Angeles. Gesundheit. He defined science fiction as, quote, I define science fiction as the art of the possible. Fantasy is the art of the impossible. Science fiction, again, is the history of ideas. And they're always ideas that work themselves out and become real and happen in the world. And fantasy comes along and says, we're going to break all the laws of physics. End quote. It's useful to keep in mind this distinction between science fiction and fantasy. While there might be some blurring of the lines between science fiction and fantasy in different works, the key difference is that science fiction tries to deal in the realm of the possible, whereas fantasy deals in the realm of the impossible. Science fiction follows the laws of physics, and fantasy breaks the laws of physics. But to muddy the waters a little bit, Arthur C. Clarke, who I mentioned earlier, he once wrote, quote, any sufficiently advanced technology is indistinguishable from magic. You can think about that a little bit. And finally, with the definitions, the African-American science fiction writer Octavia Butler, who wrote the critically acclaimed antebellum South time travel novel Kindred in 1979, the Xenogenesis trilogy about human-alien hybridization, and the Parable series about environmental collapse in our near future, gives us this definition, quote, science fiction doesn't necessarily mean anything at all, except that if you use science, you should use it correctly. And if you use your imagination to extend it beyond what we already know, you should do that intelligently, end quote. Here she suggests almost a stewardship for science fiction. Science should be used in the story correctly, and the imaginative extrapolation should be developed intelligently. That it uses the mind, rationality. There is, in a sense, a responsibility built into her definition. So, what does science fiction do? Given these definitions of science fiction, it's important to think about how they apply to all different forms of media. Science fiction is a narrative genre or a category or type of story that follows those definitions that we just encountered. Teasing out some points from these definitions, we get this list of things that science fiction does. We mentioned before the Godwin experiment. There's that extrapolation from the here and now. When we refer to here and now, we mean the present time, or the present time that the writer or the filmmaker was making their book or their movie. There's the effect of science and technology on individuals and society, that none of this stuff takes place in a vacuum, right? That whenever new technologies get introduced, such as like you can probably think of today, the smartphone many of you are using right now, is like one of the most revolutionary technologies, both in terms of what it enables us to do, but also how it's changed the way we socially interact with one another in different ways. Everything from the way that we communicate, messaging friends and family, to even the way that we date. I mean, this is the way that this technology changes our social relations. Again, it's always about humans, for human beings. You don't write science fiction for robots. Maybe one day that will change. Actually, if you ever read, how many people have seen the film Blade Runner? All right. So the book that the film is based on, Ridley Scott directed the film. The book is called Do Androids Dream of Electric Sheep by Philip K. Dick. And the neat thing about the story is that the androids that are escaping from Mars, coming back to Earth where they've been outlawed, the way that they find out about Earth and like what Earth is like is because people have been sending like essentially care packages on rockets to Mars. And in the care packages, these androids are finding like science fiction magazines. And so they're reading about Earth through the science fiction. So it's a very like, breaking the fourth wall, a meta type element in the story that they had to leave out in the film for obvious reasons. I mean, that kind of slows things down. But the final two things here for science fiction is that also fuel for the imagination. That was my experience, and I think a lot of the experience of a lot of scientists and engineers and technicians. You identify science fiction as being something that inspires them to do some of the work that they do or to follow their path in their career. And then I think it also provides a motivation to learn more because you want to kind of understand what's going on in the story beyond like simply what might be given in the story. And also to find out as you I'm sure you can think about, and you'll probably encounter. There's lots of ways that like our books and our movies get things wrong a lot of the time. The final thing I wanted to mention about science fiction before going through the examples is think about science fiction as a spectrum. You see I got this line down here. And for science fiction scholars, we refer to science fiction as science fiction or capital SF. And in a general sense, you can think of that being the good science fiction. The science fiction that has good character development, has good strong stories, that tries to use accuracy with the science and technology that it includes. Whereas there's this other term that a lot of people are more familiar with called sci-fi. And the thing about sci-fi is that it's a term that comes out of the 1950s during the B-movie science fiction movie boom. And today, at least from science fiction scholars' perspective, it's a derogatory term. We don't use it to describe science fiction. So if you want to you'll be able to pull out your I'm a science fiction expert card. You correct people whenever they say, hey, you want to go see this new sci-fi at the movie theater. You say, no, it's science fiction. But another way of thinking about this is the good stuff being science fiction and maybe the bad stuff being sci-fi. You can see one of the things we'll talk about today that if you haven't seen it, I highly recommend it, is the film Interstellar. There's the film version of 2001: A Space Odyssey by the film director Stanley Kubrick. Then we're starting to get into more recent stuff like The Expanse, which was on SciFi Network, spelled differently, and now it's been picked up by Amazon streaming. Babylon 5 was another pretty solid science based science fiction show about a space station, and a lot of the classical mechanics that were observed in the show were accurate. More about politics and interpersonal relationships. We get things like Star Trek, though, where I kind of put more to the right of sci-fi because of this thing that you might have heard of called technobabble. Anybody know what technobabble is? No? So technobabble is the thing that you'll often see in Star Trek. So if you think of Star Trek The Next Generation, engineer Geordi LaForge, he's trying to work on the engines because the Enterprise is broken down. He'll string together 12 different nouns, verbs, and adjectives that relate to science and technology that don't necessarily have anything to do with one another. But it uses what we call the rhetoric of science and technology. It's meant to sound science. It's meant to sound like technology, but it's not actually accurate. But there are times, though, that it crosses back over into the good stuff. But you get things like Transformers, Danny Boyle's Sunshine film. A little aside, be careful if you ever badmouth a science fiction movie. So when I was studying at Liverpool, I went to the premiere of Sunshine when it first opened. Now Danny Boyle was in London. He's a UK citizen. He was in London at the big premiere. Unbeknownst to me, in the row right in front of me was all of his family. And so when the film was over, I was bad-mouthing the movie to some of my friends that were in the science fiction program, explaining how this is the most ludicrous, dumbass movie I've ever seen in my life. The people in the row right in front of us are turning around shaking their fists at me, and I don't know what's going on until I overhear some of them talking and figure out okay, maybe we should go back to the norms now. So yeah, be careful who you may say bad things about their science fiction movies. But you can see also Star Wars. My beloved science fiction film series is way over here on the right in sci-fi territory. Again, because it has terrible science. A lot of the stuff is more fantasy, like the Force. Even though George Lucas tried to use these midichlorians as being the scientific explanation for things, it's still just really bad science-wise. Anyways, good adventure story, but outside that, I won't say it's good science fiction. Another way to think about it is from this science fiction writer here, Theodore Sturgeon. There's a thing called Sturgeon's Law. It's on Wikipedia. You can look it up. 90% of everything is crap. Applies to science fiction, applies to everything. So here's getting to the good stuff that I prepared for you guys today. So from that Open Lab post that I had given to your professor earlier that hopefully you can take a look at again. When you get a chance, you might want to read some of those stories I linked to. All the stories are available online that I linked to. The only thing that you can't watch online for free is Interstellar. Well, I mean, there are ways to get around that, but otherwise you need to find some streaming service or get like a DVD or Blu-ray to watch that. But you can read these stories that I've talked about today. So the first one is Tom Godwin's The Cold Equations. And it was originally published in the August 1954 issue of Astounding Science Fiction, John W. Campbell's magazine. So Tom Godwin was a fine writer in the Campbellian and Astounding traditions, but he published only about 30 stories in his lifetime. He had a real rough life. Family issues caused him to drop out of school after 3rd grade. He had kyphosis. Anybody know what kyphosis is? It's a really bad curvature of the spine that leads to humpback. So, I mean, he's like in physical pain most of his life. He did have a short stint in the military before the curvature really expressed itself, but you imagine with that pain and everything, he started drinking, he became an alcoholic, things spiraled downhill. But he is credited with this particular story, which is still widely read today. It is considered an example of something we call hard SF, hard science fiction, which Alan Steele defined in the New York Review of Science Fiction in 1992 as, quote, hard SF is the form of imaginative literature that uses either established or carefully extrapolated science as its backbone. Very few stories actually pass muster as true hard SF. We're used to like the Disney-fied, optimistic view of things, that stories should have like a happy ending. With hard SF, that's not the case. The idea is that you have to obey the laws of nature as well as like whatever constraints you build into the story, and sometimes things don't always work out that way. And the thing about this story is that Godwin tried many times to give the story a happy ending, which I'll describe in a second, but Campbell, his editor, kept throwing it back in his face saying, no, you're violating physical law in this way. You've got to go back to the drawing board. You're going to have to rewrite it and then resubmit. So the story concerns a distant planet called Woden that has a medical emergency and is in need of supplies. A cruiser, if you imagine like this large spacecraft, sends out what's called an EDS, an emergency dispatch ship, with only enough fuel to travel to Woden and safely land with its lone pilot and the needed supplies. Unfortunately, a teenage girl who wants to see her brother on Woden hides aboard the ship. When discovered, the pilot has to follow protocol and eject the girl from the ship due to her additional mass that she brings aboard the ship. Allowing for the additional mass might lead to the EDS not having enough fuel to safely land on Woden. After letting her talk to her brother via radio, she is ejected from the ship via the airlock so that the mission can proceed as planned. The cold equations are those that govern classical mechanics and the efficiencies and operation of the EDS and its rockets. I would encourage you to read the story when you get a chance and devise your own way of saving the girl. There's a lot, you can look online. Lots of people have come up with alternate explanations, other ways of getting around these cold equations that are in the story. But considering the cold equations of the physical world, the story, I think, also asks us what can be done to avoid such a tragedy, such as through better design, backup systems, reserves, or even just simply better security so that people can't sneak on to a really important mission like this. So it can ask us questions to think through and avoid these things. So the cold equations don't necessarily have to be as cold as in a manner of speaking. This next story that I wanted to share with you guys is by Cleve Cartmill called Delany. Now, astounding editor John W. Campbell Jr., who I mentioned earlier, worked with Cartmill to develop this story about warring nations on another planet with the comically veiled names that correspond. If you look at the two names here of the warring nations, Zixa and Celia, What did they, can you like transpose those letters and make words with them? Anything that pop out to you from that? How about Axis and Allies? Okay. Also pay attention to the date, March 1944, right? All right, so we got these stand-ins for the Axis and Allies, where one of them is developing a nuclear weapon, and a secret spy is trying to stop the weapon from being used. It's a very, very bad story. But what's interesting about it is how detailed it is before the general public knows anything about nuclear weapons and the United States Manhattan Project. This is before Fat Man and Little Boy were dropped on the cities of Japan. Conjecture about an atomic weapon was obviously known in physics circles for decades, and other writers had written about their possibility, but the level of detail, even though some key elements of the bomb design wouldn't have worked in the story, such as the use of uranium powder encased in an iron shell. I mean, if you had it sitting there for long enough, the heat from that powder would have melted the iron casing, so that's out. And also they used too little of a mass of U-235 to actually achieve critical mass in this imaginary bomb. Nevertheless, it attracted the attention of Los Alamos's Counterintelligence Corps, who showed up at the offices of Astounding in Manhattan, demanding an explanation from Campbell. Campbell's hubris, meaning like, his feelings of like, superiority, of overarching, of like, trying to go beyond certain boundaries during these war years, to essentially thumb his nose at the establishment and the voluntary censorship board, in effect during the war years, nearly got the magazine shut down forever. I mean, he didn't know how bad it was. Researchers have gone back through information requests from the government and discovered that he got really close to himself maybe going to jail, to having the magazine shuttered, etc. Campbell began to censor stories, though, following the publication of this story, after he got a little bit of attention from the authorities. It's perhaps lucky that the intelligence offers didn't look too closely in Campbell's office at a map that he had on the wall, where he put push pins wherever someone had a subscription to the magazine. Because you could look at the map and you would be able to identify Oak Ridge, Tennessee. Why in the middle of nowhere in Tennessee are there like as many subscriptions as there might be in like New York City? Well, Oak Ridge was part of the processing facilities for the Manhattan Project. Or all the pins that were in Santa Fe, New Mexico, not that far from Los Alamos, where they were constructing the bombs. So if someone knew what to look for, there was telltale signs about what was going on, because the scientists, the engineers, the technicians that were responsible for building the bombs were reading science fiction, and they were wanting to get their issues, even when they were in these out-of-the-way secretive places. The story, as well as the events surrounding it, raised questions, though, for us about open versus closed development, when physical law is obviously open to everyone, as well as the anti-American censorship that took place around that time. So there's other things that like the story can conjure beyond just simply what the story is about. Then we have Kim Stanley Robinson's The Lucky Strike. Kim Stanley Robinson, this fellow right here, is an American SF writer who, like Ray Bradbury, just coincidentally, was born in Waukegan, Illinois, and then moved to California when he was in his youth. He has a BA in literature from UC San Diego and an MA in English from Boston University. His science fiction tends to focus on ecology and the climate crisis, including environmental collapse as well as terraforming, which is like you're using technology to transform a barren world's environment into one that's more supporting of life. And also how the choices humanity makes in the face of ecological challenges affects us on a societal and individual level. His Mars trilogy of novels, which are about the colonization and terraforming of Mars, are very good both in terms of the science deployed, but also the political machinations that move the stories forward. I highly recommend the Mars books. The first in the series, Red Mars, is really good. I've taught it before in English classes. For today's lecture, I wanted to continue on these different stories relating to particle physics and radiation with the story, The Lucky Strike, and an essay that Robinson wrote later, that deconstructs the idea of the story called A Sensitive Dependence on Initial Conditions. And I've linked to both of those from the Open Lab page. The Lucky Strike is an alternate history story, meaning the writer takes a known historical moment and changes it a little bit in order to tell a different possible future based on that change. In this case, he imagines the Enola Gay, the B-29 that dropped the first atomic bomb on Hiroshima, Japan on August 6, 1945, crashes during a training exercise before that fateful mission. So a new crew has to be put together under this fictional character named Captain January and his B-29 called Lucky Strike. However, on the flight, January purposefully drops the bomb so that it misses the target, detonating, so obviously showing the Japanese like we have this terrible weapon, but doing so in a way to avoid the great loss of life that the actual bomb caused. He is court-martialed and eventually shot as a traitor, but not before the second mission with Fat Man also missed, and a movement starts around denuclearization, avoiding the nuclear buildup during the Cold War. This story is a thought experiment, not so much exploring the science as the ethics behind what we do with our science and technology, which I think is a very important function of science fiction. Because a lot of times we get into, let's do this because we can, and not always pausing to think, is this something should we do? Or should we put some kind of safety or constraints around what it is we're attempting to do with our science and technology? The next story is by Samuel R. Delany called I and Gomorrah. So you can see there's like some biblical connotation there as well with Gomorrah. Originally from Harlem, Samuel R. Delany is an extremely influential African-American and gay writer of science fiction. His writing ability and his self-taught expertise on linguistics and literary theory led to his teaching writing and literature at major universities since 1988. He recently retired from Temple University in Philadelphia, where he lives. And he was the keynote speaker for the second annual City Tech Science Fiction Symposium we had back in 2017. He came to campus, gave a talk, and gave autographs. Really nice guy. So the story, I and Gomorrah, is another story influenced by particle physics and the effects of radiation on the human body. In this story, spacers, they're called spacers, are astronauts who are neutered before puberty so that their reproductive organs are not damaged by cosmic rays and the hard radiation that they encounter in spaceflight. This connects to ideas from the early days of the space race in the 1950s and 1960s. There were questions raised. Is it easier to construct spacecraft and spacesuits that protect the astronaut? Or is it simply easier to adapt human beings to these really harsh environments that we wanted to go into? This idea of cyborgs, a word you've probably heard before, C-Y-B-O-R-G-S, cyborgs, or assemblages of human beings and machines, first took form during that era. Cyborgs were an idea like in reality, as much as they were an idea in science fiction at that time. Returning to the story, there are some unmodified humans who are fetishists, who desire spacers despite the fact they are androgynous and lack sexuality. They lack any sexual desire. But these fetishists really are attracted to these spacers. And in the story, they're called Frelks. It's like a derogatory term. The Spacers prostitute themselves to the Frelks, both as a joke, so like these idiots are giving us money and we can't like really do anything, but also the Spacers are really lonely. It's like they can't have the same kind of bonds that we can make with another human being because they lack that kind of desire. So the story shows how technological interventions in the body can have unintended consequences for those whose bodies are altered, as well as the change in culture around those people's altered bodies. And this brings us to one of my favorite novels, Joe Haldeman's The Forever War. And I linked to a story that was essentially cut from the novel, but it actually illustrates the main idea of the novel. So you can read that. You don't have to read the whole novel just to get the idea of it, called You Can Never Go Back. So Joe Haldeman is a Vietnam War veteran who turned to writing following his demobilization from the military as a way to cope with like the horror and the disconnection he felt when he came back to the United States from Vietnam. The novel, The Forever War, and the excise short story, You Can Never Go Back, are about a war between humanity and an alien race. Due to a misunderstanding and an inability to communicate between species, humanity and these aliens go to war with each other. To reach the aliens where they live, human beings have to fly at near relativistic speeds, connecting back to some of the ideas of your class, to so-called collapsars. In this case, collapsars would be above the Chandrasekhar limit and are essentially black holes, which in the story are believed to be connected to other collapsars forming forming a wormhole. This isn't scientifically accurate, but it's an idea that was circulated at that time. Before even the term black hole was popularized. Due to the near relativistic speeds to and from the collapsars on their way to battle, the soldiers deal with extreme time dilation, meaning the time for them goes at a much slower rate than for those people that leave back on Earth or for the aliens that they're going to visit. On subsequent battles, the enemy returns with more advanced weapons because they had more time while the soldiers were in transit to develop new weapons. And then on subsequent returns to the home front, their societies have changed. They, not only in terms of their cultures, but their sexual mores, their language, all these different things have changed. And so it leaves the soldiers disconnected both from their job in a sense of being soldiers as well as being members of the human race. Let's see. Obviously, many years pass for the aliens and the human societies, while only short periods of time pass for the soldiers, which makes them feel disconnected from home and helpless on the battlefield. And then this, in terms of the novel, serves as a metaphor for the American soldier in Vietnam. So it's like using science fiction to help people kind of understand what it was like to be a soldier in that war, to try to build some empathy with the plight of soldiers. Or when I also just mention CF period. Anybody know what that stands for? It's a Latin phrase. CF period. Confere means to compare. You might see it whenever you're reading in your textbooks. Good to know. So in this case, I say compare Bill Campbell's Sunshine Patriots, a book from 2004 with this. Bill Campbell, really nice guy, went and had drinks with him once at Manuel's Tavern in Atlanta many years ago. But Sunshine Patriots is a science fiction novel he wrote. Not so much the same kind of story as The Forever War, but it's related to a term that I mentioned before about cyborgs and about how soldiers are becoming increasingly technologized through different types of technological interventions, and how this makes them both seemingly inhuman, but also desirous of more human-like experience, more connection to nature. Really good book, and I think you can even get it as an ebook now.
All right, so let's see, we got Nightfall, we got Douglas Adams, and then we're going to get to the last thing that I'll talk about, which is Interstellar. So we're almost there. Doing great on time. So this story here is Isaac Asimov's Nightfall. It's from 1941, September 1941, astounding. And it's about the effects of the natural world on society. Campbell gave Asimov a quote from a poet you might be familiar with, an American poet, Ralph Waldo Emerson. This is from an 1836 essay called Nature. It's, quote, "If the stars should appear one night in 1,000 years, how would men believe and adore and preserve for many generations the remembrance of the city of God?" Some deep stuff there. And so Campbell gives this quote to Asimov and says, make a story around this quote. And that's Nightfall. And what it's about is it involves a 6-star system. And within this 6-star system is a fictional planet called Lagash. One night, about every 2,000 years, the inhabited parts of the planet fall into darkness. If you imagine, for like 2,000 years, where people live has always got sunlight, right, from these different stars that are going around. And then in the dark, seeing the billions and billions of stars, to do a little bit of Carl Sagan there, drives the population crazy. First realization that they had is that there is more to the universe than their planet and their immediate solar system. The multitude of stars reveals how small and insignificant the people of Lagash are. However, there are alternate takes on this, such as NASA's pale blue dot photo, which if you haven't seen before, do a Google search later for pale blue dot, and then switch over to images. And it's a famous image taken by the Voyager 1 spacecraft. It was one of the first spacecraft that actually left our solar system. In 1990, when it was really far out, it hadn't left our solar system yet, it was really far out, Carl Sagan convinced the administrators at NASA to basically have the spacecraft turn around and have the camera look back to take a family photo of all the planets, including Earth. And Earth, in this family portrait, is one single blue pixel, amazingly suspended in an array of light. Just the way the light caught on the lens of the camera gives it this effect. But it's like everybody who's ever lived, and whoever will live, at least while we're still bound to this planet, are on that tiny blue dot. And Sagan, the reason he wanted us to do this was to show like how fragile our planet is, how important it is that we take care of it and take care of one another. That a lot of like our strife and separateness is ludicrous whenever you look at everything from that kind of faraway perspective. So I don't necessarily think we would all go crazy in this circumstance. It actually may be a way of bringing us closer together. A fun example, or a couple of fun examples I wanted to mention, is Douglas Adams, UK writer, unfortunately passed away very young. Was an English writer, humorist, and Macintosh computer enthusiast, who wrote The Hitchhiker's Guide to the Galaxy and its subsequent sequels, as well as Dirk Gently's Holistic Detective Agency. And what he does, what makes these books so fun, is he takes the counterintuitive ideas of quantum mechanics and applies them to our macro world. So, the things that happen on the quantum scale obviously are a lot different than our everyday experience. But through the stories in these books, he turns it upside down and shows like some inventive ways that they could have some application in the real world. Not necessarily scientifically accurate, but it provides a lot of humor for what's going on in the stories. One of those is this passage from The Hitchhiker's Guide to the Galaxy I wanted to share with you on the infinite improbability drive. This is a type of starship drive in the story that drives a starship called the Heart of Gold. He writes, The infinite improbability drive is a wonderful new method of crossing vast interstellar distances in a mere nothing of a second, with all the tedious mucking about in hyperspace. It was discovered by lucky chance and then developed into a governable form of propulsion by the Galactic Government's research team on Damocrat. This briefly is the story of its discovery. The principle of generating small amounts of finite improbability by simply hooking the logic circuits of a Bambolini 57 sub-meson brain to an atomic vector plotter suspended in a strong Brownian motion producer, say a nice hot cup of tea, were of course well understood. And such generators were often used to break the ice at parties by making all the molecules in the hostess's undergarments leap simultaneously 1 foot to the left, in accordance with the theory of indeterminacy. Many respectable physicists said that they weren't going to stand for this, partly because it was a debasement of science, but mostly because they didn't get invited to those sorts of parties. Another thing they couldn't stand was the perpetual failure they encountered in trying to construct a machine that could generate the infinite improbability field needed to flip a spaceship across the mind-paralyzing distances between the furthest stars. And in the end, they grumpily announced that such a machine was virtually impossible. Then, one day, a student who'd been left to sweep up the lab after a particularly unsuccessful party found himself reasoning this way. If he thought to himself such a machine is a virtual impossibility, then it must logically be a finite improbability. So all I have to do in order to make one is to work out exactly how improbable it is. Feed that figure into the infinite improbability generator, give it a fresh cup of really hot tea, and turn it on. He did this, and was rather startled to discover that he had managed to create the long sought-after golden infinite improbability generator out of thin air. It startled him even more when, just as he was awarded the Galactic Institute's prize for extreme cleverness, he got lynched by a rampaging mob of respectable physicists who had finally realized the one thing they really couldn't stand was a smartass. So it's that kind of thing where he plays with some of the ideas from science but does it in like a comedic way. So it's not something you're necessarily going to like learn new science in the way that Hugo Gernsback told us that science fiction should be something that teaches us something, but it's a way of showing that science can also be funny if you're using it the right way. And then finally, we come to Christopher Nolan's Interstellar. The 2014 film Interstellar, starring Matthew McConaughey, Anne Hathaway, and Jessica Chastain, was directed by Christopher Nolan, who you might know from like the Dark Knight trilogy and other SF films, including The Prestige and Inception. Now, the film's original treatment was co-wrote by a theoretical physicist that I mentioned earlier, Kip Thorne, who also served as the science advisor on the film and worked closely with the special effects company DNEG to provide them with equations for a new rendering engine, basically the thing that creates the computer-generated visuals, called double negative general relativity, or DNGR, a relativistic renderer. DNEG was responsible for creating the visuals for the film's wormhole, the supermassive black hole Gargantua, the tesseract, which is a four-dimensional object that in the film uses 3 dimensions of space and time as uses the 4th dimension, and projected space background. So whenever you look through the windows of the ships in the movie, that's actually projected on a really big screen. It's really fantastic, visually, the way they did that. The film's compressed story allowed for a greater realization of time dilation due to the proximity to the black hole's event horizon, such as when Cooper and Brand returned from Miller's ocean planet to the Endurance to find out that 23 years had elapsed aboard the ship for Romilly, who had stayed aboard the mothership. Now, Kip Thorne advocated for visual accuracy of Gargantua in terms of the black hole's necessary fast spin for there to be the kind of time dilation that's shown in the film. But the director overruled it because he was afraid that the audience wouldn't understand both the asymmetry of the black hole in relation to the event horizon, and then the Doppler color shift that would also be present in light around the black hole. Therefore, the black hole spin was reduced in order to create this better visual effect, at least in terms of like the director's artistic vision. Now, I say this is an exciting time for all of you to be learning about modern physics. I remember in those books I mentioned at the beginning of the lecture that this picture right here was often included as an example of a suspected black hole. The X-ray source called Cygnus X1. This X-ray source is a binary system with a blue supergiant variable star and is part of the northern skies constellation known as the Swan or the Northern Cross. Now, so you imagine like this is something debated about if it's an actual black hole. But this is why we're living in interesting and I think really cool times. You can see here the center of the galaxy M87. So today we have something far more remarkable than that image of Cygnus X1 or the visual effects of Gargantua in the film Interstellar. Here you can see something that I hope that you all saw around April 2019 of last year, the first images of the black hole at the center of galaxy M87. The Event Horizon Telescope Array collected radio data, and computers used that data to reconstruct an image of the radio source, being this black hole. Dr. Katie Booman was one of the team members responsible for creating the visualization software that created the images from the telescope data. Now she has a job at Caltech. So just to conclude things, to tell you about some things you can check out. You can look on StarTalkRadio.net, and you can listen to the episode that I talked with Neil deGrasse Tyson about the relationship of science fiction and society. We had a really good conversation in his office over at the American Museum of Natural History in the Hayden Planetarium. And I think the guest of the program was Gail Ann Hurd. She's like the producer of Terminator, The Walking Dead, and a bunch of other science fiction movies. So it was a really neat show. And you can like stream it on your phones or online. And then also just want to give a shout out to the Science Fiction and City Tech website, which you already have a link for, but also my website, dynamicsubspace.net, where I share some of my research involving science fiction and other things that are taking place regarding science fiction here at City Tech. So I appreciate you guys like listening today, and we are out of time, right? 3:45?
Yeah, I mean.
Anybody have any
The
questions?
next person is not here. So.
Okay, well, if anybody's got any questions, I'm happy to answer them.